Hello guys, welcome to another video on Bluetech environment stack tutorials. Particularly, we are looking at JavaScript. In the last video, we looked at JavaScript um, numbers. We ended with big, not integers, like big integers. We saw JavaScript cannot represent very big integers. It actually rounds them up to infinity, or rolls them over to infinity, or they overflow to infinity. But by using stuff like n, we saw we can get really big numbers. So for example, I'm going to try some other one. So we can say let um, big num be equal to let's say 2000. If we say 2000 or 2 this thing to the power 2000 to the power 2000 3000, we are really going to have a very big number. So let's print that out. So print out big num. Let's see big num. So let's see what we get. We may get something good. All right, so infinity. Now if we want it to be a big number, we can add n on either side. So we will add n here. We have a big number, can't convert big. Okay, we must add n to both sides. So yeah, let's see this to be sure everything works. All right, so you see the number is so big, really very big. Look at the number. Look at the number. So big, so big. So normally JavaScript won't like to display that if it's not really a big number. So you can, when you want to use very big numbers, you may never need to use this kind of numbers in JavaScript, because even if you're dealing with the finance of the whole world, you will never need to use such large numbers. So but let's just it's just wise enough to show, because maybe some libraries you may come across, or APIs like Python can handle big numbers. So if you need to use some APIs which will need to work with the Python stuff with JavaScript, you may need to use big numbers like this. So that's the way you can use big numbers. So big numbers can be used in different ways. You can use big numbers even to represent small numbers. For example, we can say if you print 400n, it's just a normal number. But this C, you see, normally when you want to do arithmetic operators, both numbers are supposed to be big numbers. You understand? You can't convert a normal number to a big number except you use what they call big int. You can use big int to convert a number to big int. Don't know why it doesn't show here. Let's see, 2, or maybe the browser is not aware. So it looks like the IDE is not aware of this function, object, big int. But you can use big int to convert a number to a normal or a primitive integer literal to a big int. You can use that. You saw if you don't use this, you're going to get an error. Yeah, full. So let's say, for example, we can have big int like this, and as you see, just a normal big int. And you can do operations with big int, but you need to add n at the end. It's a big int. So next, we need to you can also represent other numbers with big ints, not only even your hexadecimal numbers like this, 23FFEE. You can use big ints with them in this case. So you can add n there and it becomes a big int. Let's see, I don't know. Let me see, let me be sure whether this is possible. Alright, that's possible. Yeah, but the browser is not aware, that's the problem. So you can also use ob, not the browser, sorry, the IDE is not aware of that's possible. It's giving some errors. So here we have another big binary numbers, and we can use it also for octal numbers. 3, remember, octal numbers cannot have 8, it's an error. So you can only have something like this, and I think there we go. So invalid big in syntax. Why? Okay, sorry, O's and letter O, number O followed by letter O, so it's okay. All right, so next we can also do arithmetic operations, minus, like I told you. n, you can say divided by n. So remember, if you want to convert a normal literal to BigInt, for example, if you have a function called BigInt add that takes a and b. This can be large numbers, but your function assumes they are BigInt, so you need to be sure each one is a BigInt. So you can say return, you can say BigInt a plus BigInt b. Alright, so BigInt a plus BigInt b, and now you can, once you return it, you can call our print function to just print it out. Print BigInt add, and we can pass it 200. Why we must use BigInt? Imagine we pass it 205, comma, you know, if we pass it 205, it's going to work. But what if the first value is an n, and maybe we mistakenly just say return, for example, a plus b? Now we're going to get a problem because it's going to try to add you see, it's trying to add 200, which is a BigInt, and 5, which is not a BigInt. So that's why sometimes you're required to do this, just to be sure everything is going to be a BigInt. So it converts everything to a BigInt and then adds them. So there you go. So you can do normal calculations, addition, multiplication, division, and there's also one operator which you can also use, the modulus operator. Modulus operator is just like let's say um, 2, the remainder when you divide something. For example, the remainder when I divide 10 by 2 is 0. 10 divided by 2 is 5, remainder 0. So this is going to give me, sorry, modulus is percentage. This 10 modulus 2 is going to give me let's see, sorry, print 10 modulus 2, 10 modulus 2. So I like to use spaces between my operators, but you can. So there we have 0, but say let's say 10 modulus 3, I think it's going 9, it's remainder 1, I think. Let's say 369, yes, it's 3, remainder 1. So you're going to have 1. So just know modulus is the remainder when you divide the left hand operand by the right hand operand. So if I divide 11 by 3, I'm going to have, I think, 2 or 4, something, 2. Alright, so just know this another operator is called the modulus operator. So you can also use it with BigInt, for example, like this, and it's possible. So, and you can use all the operators. I don't want to go through all. It's possible to even use minus, which we all know. So and it's possible to also use 11 to the power 3. So you can use all these. You saw us using this in the previous time. So there are just a few things you can do with BigInt, and I want you to know all that is possible. You can do any mathematical operation with BigInt, and it's perfectly valid. So you can do that. Before we move on, with comparison operators, you can mix ints. For example, I can say, normally with comparison operators, for example, I can say 11 less than 3. Is that true? Let me check. False. 11 is not less than 3. I can mix up here. You saw with the other, with arithmetic, you can't do it. You see, it's false. So with comparison operator, you can use it on both sides or not if you want. It's 11 less than 15. 15, true. So true. Yeah. So just know with comparison operator, you can mix it up and you have no problem. It's 11 equals to 11. You see, let's check it out. You see, true. So they are equal to, that is 11 equal to 11. I'll teach you this later on. Let's see, false. Why? Because this object, this is a primitive integer, while this is a BigInt integer. So they are not, the objects are different. The value is the same, but they are of different objects. So when you use 3 equal to sign, you're checking whether they have the same type. type. For example, if you say print type of 11, type of 11, you're gonna get number, which shows that there number. But if you say print type of 11n, you're gonna get int. So BigINT. So you see, triple equal to sign compares the type, not the value. It actually compares the type. Yeah. So if you say 1 equals to true, this will be true because normal equal to sign compares this is a number, but when with boolean, 1 is true according to boolean expressions. But if you try them like this, 1 is a boolean, 1 is a number, so you get false because 1 is equal to true normally, because 1 is a truth value. We are going to see that later on. But 1 equal to true is wrong because 1 is a number and true is a boolean. So I just want you to take note of the difference between a double equal to sign and the triple. While a single equal to means assignment, you're trying to assign true to 1, which is not possible because you can also only assign, like you can only say let b, for example, be equals to 10. You can also only use the assignment operator when the left hand operand is an identifier. So you're assigning 10 to the identifier b, where you can later print out b like this and have something good. So you have an output 10. So that's just the difference. While equal to is comparison and equal to is still comparison, but it compares type and not value, while double compares value and not type. So just take note of that. All right, so before we continue, let's look at some other conversions, because what we looked at was how to use pass int, pass float, and but we can also use the number object to convert other variable types to numbers. For example, I'm going to be using this here. Let's use b, for example. Now if we want to convert let's say number, in fact, let's say my number here, we are trying to convert different numbers to numbers, so I'll just give it the identifier my number. All right, so my number equals to number. Now we can use a boolean. When we apply it to true, you're gonna see true. If you convert true to a number, it gives you 1, and if you convert false to a number, let's see, b is not defined. Oh, sorry. Here we have my number, my number, my number. All right, so if we convert that, we have 1. If we convert 0 to a number, let's false to a number, we have what we see here, 0. Now when you apply it to let's say when you apply to a number, for example, if you just passed a number like 3,500, for example, of course you have a number, so you should not be afraid to convert a number to a number. If in case, let me say you have a function that you want to that converts its parameters to number, don't be afraid. If you convert a number to a number, you're going to have an error, so you're just going to have the number, so there's no problem. Now what if you convert null? Like we haven't seen this type, but I'm going to show you. We have null. What if you convert null to a number? You're going to get 0. If you convert undefined to a number, undefined to a number, oh yeah. All right, so if you convert undefined to a number, you're going to have not a number, because undefined is like when a variable doesn't have a value, its value is undefined. So if you convert undefined to a number, it's going to give you not a number. So undefined cannot be converted. Where converted, it gives you not a number. So now, okay, so let's say when applied to a string, an empty string, initially, let's see, we should get 0. When applied to a string that cannot be represented as a number, let's see what we get. You see, we get not a number. And remember, this is different from pass int, which we saw earlier. For example, if it's 50 pixel, we're going to have not a number. But if it's 50, so if it's a valid number within the string, you're going to have a number. And if it's 50 point, let's say 9, it's a valid number too, because that's a floating point number. You're going to have a number, and even if you have negative, you should know negative is also a valid part of a number, so you should be sure. And even if you have positive, for example, you're still going to have same stuff. And positive still is part of a number. By default, all numbers are positive. Now if you have plenty or multiple zeros in front, 00050 is going to be ignored, and you're just going to have 50. So leading zeros are ignored. So let's say 0.909, you see. So you can use point for a floating point number. So we saw if it's an empty string, it's going to be 0. So in case of any other stuff, we are going to have, like if we have false, of course, false is not a valid number, so it cannot be. So not a number. So, but remember, this false is possible. I just want to show you, you should not use false in a string to try to convert. This will be 0. So it's different. Now, like we saw earlier, numbers sometimes may be a bit like not convenient to convert. If you really want to do a conversion, you can use pass int or pass float. We have already seen that earlier. So for example, like pass float works even if, like for example, 12 pixel, pass float will work. It's going to remove the pixel from the 12, and it's going to be 12, which actually converted it to a number. So you should know, but you have now, if you have something like pass int with something like this, now you have a problem. It gives you not a number. Unlike number is going to give you 0, but pass int is going to give you not a number. And if you have something like this, it's going to give you -40. So you should understand that difference between pass int and number. So it's different now. So I want you to understand that different. Now you should also understand pass int can take 0xa. For example, in, let me say, 0xf or a or whatever. That's hexadecimal. Pass int can be able to convert that because it recognizes that as 255 hexadecimal number. You can also take an octal. Remember, an octal cannot have a value up to 8. You can also take an octal. It's going to know that's an integer 0 what. So let's 0037. So let's say it's going to take OX. What of OB? Let's see OB. Let's see whether pass. We can take OB 1001. I don't know about this. Alright, it's not able. So it's not able to read that. Just so for it shows it can only look into OX, not OB and not O. So there we go. Alright, so following that, we can also only use hexadecimal literals in a string, for example. Now let's try to use it without, of course, this is an integer, so we know this will work. Of course, this is an integer, of course, so it's going to work, so there's no need to try it. Now, pass int, for example, doesn't only pass a number. For example, like you can also supply, for example, you see you can supply a radix. You can supply a radix, which is the base. So I can pass int and specify the base. So for example, so take note, you can pass, for example, you can say, for example, I want to convert ff to base 16. You see, we can use passing like this. Remember, without passing the radix, it will not know. You see 255. But look at this. If we did not pass this, it will not work. It will not work. So you should know that we can also use this now for base 8 numbers, like we try octal. So you can say 347, and you can tell it base 8. Base 8. So it's going to convert 347 to base 8, and so you have 231. So in that case now, you can use let's say even other bases I think are possible, base 12. So you can use any base you want, and you can even use base 64 if you want. So let's see. Okay, not a number. So let's see. So base 64 is mostly for strings. So you can use any base you want. Base, like you saw, base 10. There will be 347, of course, because base 10 number is base 10. So now I just want to show you, you can also pass a second parameter for pass int. All right, so to end this, let's say, for example, let me pass 100. I'm passing it in. I'm passing it as a binary number. That's base 2. Uh, it gives me 10. That's the value 10. 1010, yes, 10. And let's say I'm passing this same stuff as an octal. You see, it has a different integer value. You see 520. And let's say I'm passing it as a normal base 10, a decimal number. I'm going to get 110. I mean 110, 1010, 1010. And in case I pass it as an hexadecimal number. So you see, the radix or the base actually means different things. That's actually passes the number as different values. So you can see all of them are stored internally as integers, but the radix determines the conversion of the string from the string, for example, to the or from the string to the and remember to the integer value. And remember, this you can't do this like this. You can't do it. It must be the value passed as the first parameter must be, or let's see, right, 1010. Okay, okay, it's possible. 1010, you can do this. So as you can see, the value passed. All right, but it's not supposed to work normally. It just shows, for example, if you look at the function, it normally takes a string and then the radix can be a number. So what we see here is this is supposed to be a string, which means the function actually tries to convert this to a string. So it just allows you to do it, but normally you have to pass it as a string so you can do its conversion. So take note of that. All right, now pass float also works the same way as I've shown you. If you want to pass float, for example, you write 2.56 millimeters, for example, you see it's going to extract. Let's see, it's going to extract it, not pass float. Sorry, pass float. All right, so pass float is going to extract it, and you have 2.56. So the millimeter is ignored. Now you can also use pass float for normal hexadecimal numbers too. So if we have OX, let's say 3FF. Yeah. So let's try this. It's normal like a number or something. So you have 0. So we see if we try, what happens is because this 0 is taken as the float value. This is not a float. X is not a float, for example. As you can see, X is not a float. So the pass ends here. That's why you have 0. Just so that you know that. Then you can pass float as a normal float and you get back the float. It's 8.69 and you get back the normal float. So let's say if you add 0 here, it's going to be ignored, just like with integers. It's going to be ignored. And lastly, you can also have floats with e, for example, e to the power 3, 4, for example, and it's going to give you your floats if you want, for example. It's going to give you your float even if this was in a string, because e is a valid, you should know e is a valid is part of a valid float, so it will still give you what you expect. So I just want to take note of that. You can also use negative if you want, and you're still going to get what you expect. So just take note of that. All right, so let's end this with an introduction to the date object. We are going to learn more about the date object later on, but for now, I just want to show you an introduction because you might want to use the date object in your project. So now to create a new date object, you can just say let my date, for example, let my date be equals to, you can say new date. All right, so let's try to print console.log that date out, or let's use print. Let's print my date. Now you may have let's print my date. So you see it tries to convert the date to a some kind of, like, this is the full date. We have Wednesday, May, everything GMT and everything West African Standard Time. So like the UTC time, the full date string plus including the time. So that's an example. Then what if you want to get the current date? You can just, instead of saying this, you can say let today be equals to new, or you don't even need, you can call the static now method in the date function. So here is the start, so you can say this and you can print today, so you don't need to create a new object. So you see, and what you get. All right, so what is returned is actually the UTC time. Like you can see, this is the millisecond, the number of milliseconds of like since a particular time. I don't know the origin, but for now, so all right, so this should be the UTC timestamp in Unix. Usually it's called Unix timestamp. So it's the number of milliseconds since January 1st, 1970. So just know it for now. You don't need to worry about the details, but it's usually called the Unix timestamp. So that's what we get when we call date.now. We get it as a timestamp. Timestamps is very important. It's usually used with database applications when you need to store the time when something was updated. Like the last thing in WhatsApp, maybe use a timestamp because it's easy to compare timestamps than comparing dates. If one timestamp is greater than the other, it means that date is later than the other. If one timestamp is less than another, so you just compare them like normal numbers. So you can use it to compare differences between instances. So it's very easy to do mathematical operations on timestamp than to do mathematical operation on date values like 2000 as this minus 2000 and that, all those type of things. So just take note of that. All right, so we can also do this like this, where we have my date equals to date dot now, and then we can also say that we can say, let's say, new date, and we can get, can say my date dot get time. All right, so my get dot, let's see now what we get. All right, so you see the seconds are changing. Just take note, every time we refresh it, you see the seconds are changing because seconds are growing. So here's the number of milliseconds since 1st of January 1970. So as you can see, all right, every time it changes. So you can use it for a bit of, most times if you want to create file names, we usually write a function that makes use of this. I'll show you that later on. You can use this to create some uniqueness in file names. You can use now to create random file names. So here are them. You can see they keep changing every second. So there we go. So the next stuff we're going to look at is to convert the string so let's say ISO to ISO string. Let's try to convert our date into something readable. So let's see, sorry, it's a function, not a property. All right, so you see this is an ISO string. It's quite complicated, but you can write it in a simpler form by using to date string. Let's say to date string. It makes it look better. So let's see this. All right, you can see, oh yeah, Wednesday, May 18th, 2022. That's today's date. You can also say to time string. In this case, you're just going to see the time. Remember that one only has a to time string. As you can see, this one only has dates, no time. So you want to get time, you can write to time string. Here we have 1704 and the time of today, and here we can have to local time string. So let's have to local time string, and we'll see to local date string. So here is a simple time which you can use in your programs. Here is to local time string, and we can have a simple to local. We can even have to local string, which will give us both the time and date. So we have here, we have the dates and we have the time, and now we can have to local time string. So you can just use any of this in your simple date application. So here is a better date, 5:05:26 p.m. So there are some simple functions about with the date objects. We are going to see we are going to look at the date object into more details later on in these tutorials. But for now, here are just a few methods in the date object you can use for your simple applications. Alright guys, so I guess that's it for today. In the next video we are going to look at undefined, booleans, null, and undefined. So those are the data types we're going to be looking at. And after that, we are going to look at symbols. So, all right, see you in the next video and have a nice time.